you saw that on my sign up sheet, but you might want to be part of that. It's a 90-minute session. And there's a lot of people that are doing pre-calculus that are meeting with that. So that might be something you look into for the next time, Tuesdays and Thursdays.
Is that like a group thing?
It is. Yep. It is up to 3 people at a time for an hour and a half.
Okay.
But it's nice when everyone's doing the same thing. And a lot of times there will be people doing pre-calculus. So that's probably the most common thing that I've been doing. So anyway, all right. So we're talking about rational functions today. It looks like I'm going to go ahead and clean this up just a little bit on my computer, so it's easier for us we have more to work with, more room to work with here. Okay. So this says they basically wants me to graph this entire thing. So in order to graph it, let me make this a little bit bigger. Okay. You see that okay?
Yeah.
All right. So the first thing to do, it says tricky. Okay. The first thing to do is you're going to factor the numerator and the denominator if possible. So the top factors into x and -5 and +1, right?
Yeah.
You good with that?
Yeah.
And the bottom factors into it. It's already factored. Hey, this is why they're saying tricky, because what actually happens is this actually just turns into a linear equation. So it actually doesn't even look like a rational function. It's just going to have a hole in it. You understand what I'm saying? So the removable discontinuity has to do with what you canceled out. So x minus 5 is what you canceled out. Set that equal to 0, and that tells you where your hole is going to be. It's going to be at x equals 5. So now I have to plug that back into my new function. So y would equal 5 plus 1, because that's x, right? So y equals 6. So there's a hole at 5 comma 6. So 5 comma 6, I'm going to just put a hole right there. And then you can just go to your function and just draw your function in. Your function is just x plus 1. And what is x plus 1? What kind of equation is that?
A linear equation.
Linear, and it goes through 1, right? And it goes up 1 over 1. So there's your graph. So it's tricky, but actually it's easier than most if you've done them before, because really it's just a line with a hole in it. So now let's name everything. The domain is going to be from -infinity to 5 union 5 to infinity. You understand that?
Yeah.
The removable discontinuity, we just said it, it's at 5 comma 6. There's no horizontal asymptotes. There's no vertical asymptote. The x-intercept, you can see it. It's already on the graph. It's at -1 comma 0. The y-intercept, you can see that on the graph. It's at 0 comma 1. As x goes to infinity, f of x goes to infinity. It goes up from right. It goes up from left to right. And as x goes to -infinity, y goes to -infinity as well, because it goes down to the left. And that's it. Questions about any of that, or you understand it all?
I think I got it.
All right. So the next question is maybe not as tricky, because it doesn't say tricky, but it might be. So let's factor what? What can I factor out of this?
Out of the numerator, you could factor a -x.
Good. So when I take a -x out, what am I left with?
An x and then -1.
Plus 1, because I took a negative out, right? Do you see that?
Yeah.
Okay. And then how about the denominator? What does that factor into? It's going to be x and x, right? And I'll give you a hint. Try x plus 1, because chances are that's one of them. So if it's a +1, it's going to be a -3, right?
Yeah.
And sure enough, that works. So what cancels out?
The x plus ones.
So x plus 1 is your removable discontinuity. So x is -1. That's where you're going to have your whole. And your new function is negative x over x minus 3. Right? So
Yeah.
your removable, let's deal with the whole first, the removable discontinuity. So we solved the factor that we canceled. We solved that for 0. We got our x coordinate. Now let's plug that back in. So your y coordinate is going to be, let's plug in -1 for everywhere that you see an x. Whoops. -1, sorry. Plug in -1 there. Got it? So that's going to equal what? 1 over -4, right?
Yeah.
So your whole is at -1 comma -1/4. And let's go ahead and just put that right on our graph right away. -1, -1/4. So there's a hole right there.
Got it.
Okay. Now the domain. So we know there's a couple of restrictions on the domain. The domain, look at our look at first of all the whole, right? So -1 isn't a part of it, but neither is 3. Right? Because we can't plug 3 in here because then we would have 0 in the denominator.
Yeah.
So my domain is, do they want me to write in set notation?
Yeah.
Or interval notation rather? Interval or set? Interval?
Interval.
Okay, so from -infinity to -1, union from -1 to 3, +3, and then union from 3 to infinity. Did I do that right?
Yeah.
Okay, now let's talk about the horizontal asymptote. The horizontal asymptote has to do with the degrees of your numerator and denominator. When the degrees are the same, the horizontal asymptote is just y equals the ratio of leading coefficients, which is -1 over 1, which is -1. So your horizontal asymptote, let me do this in red. Y equals -1. So your horizontal asymptote is going to be like this right here. I'm drawing a dashed line in red. Maybe I should have used yellow. Yellow might have popped out a little bit better. Let's see if that works better. Can you see that a little bit better?
Yeah.
Y equals -1. Maybe it's not that much better, but maybe on the graph it'll be easier to see. I think so. So there's my horizontal asymptote. How about my vertical asymptote? What's that going to be?
Isn't the vertical asymptote x equals 3?
Exactly. You set the denominator equal to 0 for this. So x minus 3 equals 0. So I'll do this over here. The vertical asymptote is your denominator. Set that equal to 0. So x equals 3. So here's my asymptote right there. Your x-intercepts are where the numerator equals 0. So for your x-intercepts, you set the numerator equal to 0. So in this case, it's just 0 equals 0, or x equals 0, right?
Yeah.
So x-intercept is x equals 0, or 0, 0, I should say. The y-intercept is also 0, 0, because you plug in 0 for x and then solve for y for that. So 0, 0 is one of my points. There it is. I'll graph it right there, the origin. As x goes to positive infinity, what happens to the y? Well, we can see right away what's going to happen, can't we? It's going to do this over here to the left. And it's going to do this. Can you see that?
Yeah.
And what has to happen to the right? Can it be up here somewhere? Is it possible? How do I know that it can't be up there?
Isn't it based off of like how many terms are in the factored numerator?
Yes, there's a couple different ways you can do it. First of all, you can just use logic and say, well, there's no other x-intercepts, right? There's only one x-intercept, so it can't be up here because then there would be another x-intercept somewhere over here. So it has to be down here. That's one thing you can do. Another thing you can do is you can look at your vertical, as I don't know if your teacher taught you this, but this is a cool little trick. Your vertical asymptote, look at the factor that you got that from. And what's the multiplicity of that? In other words, how many of those are there?
1.
There's only one. And when that's the case, the asymptote is going to approach, or the lines are going to approach from opposite sides. When it's odd, they approach from opposite sides. When it's even, they approach from the same side.
Mm-hmm.
So if this was squared here, they would approach from the same side. Yeah, and that would kind of change your whole graph. So I'm trying to like think about how that's true, but I'm pretty sure that's true. What I just told you, I'm pretty sure that's true. So, but this question actually just says, as x goes to infinity, where does f of x go? Well, they're both going to be approaching the horizontal asymptote. So f of x is going to approach -1, and f of x is going to approach -1. See, in both directions, it's approaching -1. So your graph is going to do that right there. Another thing you could do instead is you could literally just plug in one of these points. Plug in 4. Plug in 4 and see what it gives you. If it gives you a point up here, you know it's up here. If it gives you a point down here, you know it's down here. So if when I plug in 4, I would get -4 over 1, which is just -4. So that's 4, -4 would be my point right there, which I happen to be right. I happen to put it on there. So that's another thing you can do to graph these. Okay.
Gotcha.
All right. Next one. It says graph it. Same deal. So what's the domain going to be for this?
Um,
I'm sorry. Let's not do the domain. Let's first factor. What can come out of here?
2.
And what do I have left?
X squared minus 4.
Good. And what can that factor into?
And x and a -2.
Very good.
2.
Yeah. You understand that?
Yeah.
Good. And how about the bottom? What's that going to factor into?
The bottom will factor into.
One of them is going to be a -2 or a +2, I bet. And the other one's going to be a 3.
Yeah.
Which one's positive and which one's negative?
The 3 is positive and the 2 is negative.
Perfect. Good job. All right. So what cancels?
The -2s.
Good. So my simplified equation is this. But remember, x cannot equal what?
-3.
Well, for the removable discontinuity first. You're right, x can't equal -3, but what else? What did I cancel out?
The -2.
Yep, the x minus 2. So what is your r? What's your whole going to be?
The whole is going to be at +2.
Good. And then what's the y coordinate going to be? 2 times 2 plus 2 all over 2 plus 3, which is 4 times 2, which is 8 over 5, 8/5. So that the RD is 2, 8/5, or 1 3/5, right? So
Yeah.
2, 8/5, 1 3/5 is going to be right here. There's going to be a hole, so I'm going to put a hole there. Let me try that again. That didn't look too good. 2 and 1 3/5 right there. Okay. So the domain, what can x not be? Besides 2, what else can it not be?
-3.
Good. So I'm going to write -infinity to -3, union -3 to 2, union 2 to infinity. Right? There's my domain.
Yeah.
My RD I have. How about my Hasse? Do I have a HASI?
How do you tell if you have a HASI again?
So that's all about the degree. If the degrees of the numerator and the denominator are the same, then the HASI is just the ratio of leading coefficients.
So it'd be 2 divided by 1, which would be 2.
That's right. So it would just be y equals 2. So that's my HASI. By the way, the other rules are if that's not the case, if the degrees aren't the same, if the degree of the numerator is smaller than the degree of the denominator, in other words, if it's a bottom heavy, I call it a bottom heavy graph, then your asymptote is just the x-axis. Your horizontal asymptote is the x-axis.
Okay.
And if the degree of the numerator is bigger than the denominator, meaning if it's top heavy, then you're going to have a slant asymptote, not a horizontal one. And it's not necessarily a line. It could be a quadratic slant asymptote or even a cubic asymptote, but that's what you're going to have.
Mm-hmm.
I don't know if you're going to do that in this class or not. Some teachers teach that in pre-calc, some do not. But just so you know, so go back, if that confused you, go back and watch that video and you'll see. And the way you find those slant asymptotes is by doing a long division. So does this sound familiar, or have you not learned that yet?
You haven't learned the slant asymptote yet. She said she was gonna go over it either tomorrow or next week.
Okay, so you will probably get to it. So what is my vertical asymptote? But you don't have a horizontal and a slant. You can't have both of them. You have one or the other, at least for these problems. What's my vertical asymptote going to be?
For the vertical asymptote, you have to take the RD and put it back into the equation, right?
Nope, that was for the whole. We're done with our RD. The vertical asymptote has to do with the denominator. Set the denominator equal to 0. Set denom equal to 0. And solve. So what's the new denominator?
-3 and +2.
It's just -3 because we already took care of the positive.
Oh yeah.
Right. So you're setting the new denominator equal to 0 and solving, which means x equals -3, right?
Yeah.
So -3 is my vertical asymptote. The x-intercepts, remember how you find the x-intercepts? You set in the numerator equal to 0. Your new numerator. So what is that going to be? What's your x-intercept going to be? Can you see it? This doesn't matter, the 2, it's just this right here. Just set that equal to 0 and solve.
So -2?
Yeah, -2, 0. So -2, 0. Oh, that checks out. And what's your y-intercept? I'm going to show you. You set x equal to 0 and solve. So I'm going to have, if I do that, I'm going to have, if I put zeros in here, I'm going to have 2 times 2, which is 4 over 3. So 4/3 would be my y-intercept. Whoops. 0, 4/3. Got how I did that?
Yeah.
And then the behavior toward infinity and negative infinity, if you have a horizontal asymptote or even a slant asymptote, that's always the behavior toward infinity and negative infinity. So it approaches -2 in both directions. You see how it's going to approach -2 here, and it's going to approach it up here. Now, how do I know it's going to be up here again? How do I know if this, can you tell that this one has to be here? Remember, it was 4/3. So 4/3 is like right here. See how this all checks out?
Yeah.
So how do I know that this other one, I really don't even have to look. How do I know it's got to be up here?
Because there's only one factored pair in the denominator.
That's right, because there's only one x-intercept. If it was down here, I would have another x-intercept somewhere, but I don't. Okay. So it's up here, and your teacher probably doesn't really care, but if you want, you can plug in -4. You can plug -4 in right here and just find out what number you get so that you have like at least that number in here correctly. So if I put -4 in here, it would be a -2 times 2, which is -4, and -4 minus 3 is -1. So -4 over -1 is +4. So 4 comma 4 is my point. You can do that if you want. It'll help. And -5, I bet it's -5 comma 3. I bet that's my point. I don't know that for sure, but I'm guessing it is. So again, how can you check it? Plug in -5. -5 plus 2 is -3. -3 times 2 is -6. -6 divided by -2 is +3. So that just helps you kind of know roughly where your graph is going. So just plotting points, plugging in points. Okay.
Okay.
Did I go too fast, or does that make sense?
No, I got it. I think I understand it a lot better now.
All right. It seems like, yeah, it seems like you were following that pretty good. Any other questions about any of that stuff?
So,
or before we move on to the next one, do you have more in here?
there actually wasn't any more questions in there.
Okay. We can do another one, or I can show you a slant asymptote one if you want.
Can I ask you a question about these first?
Yeah.
So for the like as x goes into infinity, y goes to -2.
Right.
Is that always going to be the same as
Sorry, it's not -2.
It's just +2, right? Because it's the same as the horizontal.
Yeah, my bad. Yep. It's always the horizontal asymptote or the slant asymptote, because those things tell you the behavior to infinity.
Okay.
That's what asymptotes tell you. It tells you behavior toward infinity.
Okay.
In fact, technically, you will, you probably won't in this class get into it, but there are some rational functions that actually go over your x-intercept or your asymptote and then come back down. So it's not out of the realm of possibility to do something like that. But it's still going to be approaching it. It just will be approaching it from the top instead of from the bottom.
Okay. And then could you show me a slant asymptote one?
Yeah. So a slant asymptote, you get that when the degrees of the numerator and the denominator are 1 off. The degree of the numerator is 1 more than the degree of the denominator. So for instance, if your function is y equals, I'm just making one up, so it might not be pretty, but if it's let's see, x plus 2 times x plus x minus 1 all over x minus 3, let's say. So the numerator for this one, or so my vertical, let's see, my x-intercepts are going to be where the numerator equals 0, right? No, I don't have any holes in this particular graph. So my x-intercepts are going to be at -2 and +1. My y-intercept is going to be where I plug in 0 for x. It's going to be 2 times -1 all over -3, which is 2/3. So there's my y-intercept. My vertical asymptote is going to be where the denominator equals 0. So it's at x equals 3. Got it?
Yeah.
And I have no horizontal asymptote, but I have a SLASI, a slant asymptote. And here's how you find the slant asymptote. I go ahead and multiply the numerator out. So that's going to be x squared. I'm foiling it out. It's going to be x squared plus x minus 2. Did I do that right? Positive 2x, negative x is a positive x. Yeah, -2. So there's my what's on the top, and I'm dividing into that x minus 3, right?
Yeah.
So this is how you do it. You do long division. Now, do you remember how to do long division with polynomials?
Not really.
So I'll show you how. I'm gonna take this number here, I'm sorry, this, and divide it by this, and that goes here. So how many times does this go into this, in other words? Divide it, this by this, and you get what?
X.
You get X. Now take that and multiply it and put it here. So X times X minus 3 is X squared minus 3X. But remember, when you're doing long division, you're going to actually subtract that, right? So we have to distribute this negative in. And now add straight down. These go away. And these add up to what?
4X.
4X. Now bring the -2 down. Now ask that same question. How many times does this go into this?
4 times.
4 times. So put the 4, I'll do this in blue now, right here. Multiply this here, put it here. So when I put that there, I'm going to get 4X minus 12. And don't forget, you're subtracting that. So you're going to have a plus, a negative, and a plus. So this is actually going to be a remainder 10. So your remainder is really 10, and it would be 10 over X minus 3. That would be your remainder. But this remainder doesn't even matter. The only thing that matters is this, and that is the equation of your slant asymptote.
Okay.
So your slant asymptote is right here. Your SLACI is y equals X plus 4. Okay, so let's take a look at what the graph looks like. I have x-intercepts of -2 and +1. I have a y-intercept of 2/3. I have a vertical asymptote of 3. I don't have a horizontal asymptote, but I have a slant asymptote of y equals X plus 4. So X plus 4 means that it's going through 3, 4. It's going through here, and it's going up 1 over 1. So it's going to go through at -4 as well. That's your slant asymptote. So what does that mean? Well, I can't really see it. This is going to be a bad picture because the other part of the graph is going to be up where we can't see it. It's up in this region up here. So I did a bad job drawing it in, but this main part of the graph, I can see what's going to happen. It's going like this. Do you see?
Yeah.
And the other part of the graph, if I take this and expand it, like here was this and here was this, it's going to be like this up here.
Okay.
Okay. So in fact, let's take a look at it. Let's take a look at it on Desmos, and you can see if I literally plug that exact same thing in, help me remind me what that said. Y equals, what was on the top? X. Was it +2? What did I write? I forget.
I'm not sure either.
Okay, I've got to go back and look at the Jamboard. I've got it up on my computer. Give me a sec. But it's not showing up for some reason. All right, it'll be easier for me just to do it like this. +2, -1, -3. X +2. What did I say the other one was? -1, -3.
Yeah.
And then divided by X minus 3. And look at that graph. Do you see the slant? You don't see the slant asymptote, but do you understand?
Yeah, I do.
So that is you can see your slant asymptote is right here.
Mm.
And here's your vertical asymptote right there. And that's the graph that we were just talking about. All right. Good.
Yeah.
All right. So that's what you're going to learn tomorrow. And hopefully it'll be even easier for you. So if you're having a hard time with long division, go to my website, and there's all kinds of long division stuff on my website.
Okay. Thank you.
All right. Good chatting with you. Don't forget, you can sign up also for the in-person sessions at the